The math. That's all the math you need for computer science. In this episode, we're going to be talking about one of the deepest and most fundamental truths of linear algebra, and it's also kind of abstract. It's a little bit difficult to get your head around at first, and I've thought long and hard about the best way to teach this, and I have come up with a game. It is called the Domino game, and that's what we're going to be playing through this segment, and I really encourage you to play the game, play along. When I ask you to stop the video and figure out the puzzle, it's really important that you actually stop the video and you actually figure out the puzzle, because the act of going through the mental operations necessary to solve this game is exactly what you need to understand the big topic of this entire episode. Okay, so the domino game, here it is. These are the rules. I'm going to give you one or more starter dominoes. Those are going to be yellow. And the object of the game, the object of this puzzle, is to figure out how to build a white goal domino from these starter dominoes. Okay, so you're starting from the starter ones, which are yellow, and you're trying to build the white one. The way you build a domino is you use any number of each of the starter dominoes. So I'm going to give you two of them. You can use a fraction of a starter domino. You can even use a negative number of a starter domino. Those are a little bit more difficult puzzles, and we won't start with those. But you can basically use any number of each of them and add them together. You add the left sides together and the right sides together of each of the starter dominoes in order to get the goal domino. Okay, and we'll do an example so you can see what we're up against here before I give you the real puzzles. Now, just a couple notes. You cannot use only one side of a domino. So there will be times when I say we're going to use half a domino, but when I say that, I don't mean one side as opposed to the other. I simply mean half of the entire domino multiplied together. So we'll see an example of that. It is also true that unlike the real game of dominoes, you can't turn a domino around. So when you see there's a left side and a right side, those have to stay that way. You cannot flip the domino so that you get the opposite side. All right. So here's an example. Let's say I give you these two yellow dominoes as your starters. I say you got a 5-1 and a 2-3. And again, you cannot make a 5-1 a 1-5. You cannot make the 2-3 a 3-2. Those have to stay that way. Okay. And your goal domino in this first example is going to be 7-4. So how do you make 7-4 out of those two yellow dominoes? And here's one solution. If I take one of the first domino and I take one of the second domino, so I take 1-5-1 and I take 1-2-3, and I add those together, I'm going to get 7-4, because 5 plus 2 is 7, and then 1 plus 3 is 4. You see how that works? So you're not allowed to take a different amount of the left half than the right half. You have to take a whole domino, or 2 times the whole domino, or even a half of the whole domino. And then you can do the same thing with the other domino. Add them up means the left side and the left side add together to get you this left side. Add the right side plus this right side to get you this right side. If I'd given you a different goal, if I said, hey, how about this one here? You have to make 4-6. One solution to that would be adding 0 of the first one and then adding twice the second one. And if you do that, you end up getting 4-6 here, because 2 of these gives you 4-6. Okay? What if I said you want to get 1-8 as your goal? If you play around with this a little bit, you will discover that a solution, and there may be more than one, but one solution is -1 of the first domino plus 3 of the second one, right? And that's because if I take 3 of the second one, then I'm going to get 3 2-3s, which gives me 6-9. Now, if I have 6-9 and then I subtract a 5-1, I get 1-8. Convince yourself of that before you go forward, okay? 3 of this domino, 3 of them, plus -1 of this first one will get me to the solution 1-8, all right? And here's another example. I'm going to change up the starter dominoes here just to use this example. So if I give you 4-2 and 1-1 as your two starter dominoes, and I say I want you to try to make 3-2, one way to do this is to take half of the first domino. Now again, I don't mean half in the sense of one side and not the other. I don't mean that. I mean you're taking half of the total here. So 1/2 of 4-2 gives you 2-1. And so if I have the 2-1 domino, which I get from taking half of the 4-2 domino, and I add that to 1 of the second guy, I end up getting 3-2. All right? So get ready. What I want you to do is give yourself 60 seconds maximum. So if you can't get it in 60 seconds, go ahead and give up at that point because there's probably diminishing returns. Some of these are harder than others. We'll start with some easy ones. But for each one of these puzzles, I want you to give yourself some time. I want you to actually work through it, pause the video, and then see if your solution works. Then I'm going to give you my solution, which might be the same, might not, and you're going to be able to tell if it works. All right? Here we go. Ready, set, go. Your starter dominoes are 1, 2, and 4, 4. I want you to get 6, 8. Start the timer, go. All right, here's my solution. 2 of the first domino and 1 of the second. You may have gotten a different solution, but I think you'll agree that this one works. If we take twice the first domino, that gives me 2, 4, plus a 4, 4 will give me the desired 6, 8. Next, you want to make 3, 2 with those same starter dominoes. Pause the video and figure it out. Okay, for this one, I got -1 of the first one and 1 of the second one. Because if I take that 4, 4 guy and I subtract off 1, 2, I end up getting 3, 2 as desired. Next, you want to build 3, 4. Pause the video. All right, here was my solution. 1 of the first and 1/2 of the second. Because if I take 1/2 of that 4, 4 guy, I end up getting 1, 2 plus 2, 2, and that gives me the 3, 4 as desired. What if I want you to build 7, 2? This is a little trickier one. Pause the video, see if you can get this in 60 seconds. All right, my solution was -5 of the first one and 3 of the second one. So you work that out, you say, what if I take 3 of this domino here? That gives me 12, 12. Now if I subtract 5 of the first domino, that means I'm subtracting a total of 5 from the left 12, which gives me 7. I'm subtracting a total of 10 from the right 12, which gives me 2. Bottom line is that comes down to 7, 2 as desired. Next, what if I ask you for 2, 4? What do you get? That's a pretty easy one because we're going to say don't take the second domino at all. Heck, I don't need that one. I can do it all with the first domino. Take double the first domino and you have got 2, 4. What if I ask you to find 0, 4? How can you get that? Answer I got was 4 of the first domino minus 1 of the second domino. So 4 of the first gives you 4, 8. Then if I subtract the 4, 4 from that, I get the 0, 4 as required. And finally, last one, what if I give you both blanks? One way to figure that out is to say, well, gosh, let's just take none of the first one and none of the second one, and duh, I am trivially at the double blank domino. All right? So thinking through those things, adding up those dominoes and seeing if you can get the gold domino is going to totally prepare you for understanding the concept of linear independence, as we'll get to in a couple of segments. All right? Here's some questions to mull over for you. Think of these through. First of all, were your solutions the same as mine? I'm kind of curious. Only you know that, of course, because I'm not you, but you saw my solutions, you got yours. Did you end up with the same ones? Interesting question. How many solutions are possible for each of these puzzles? Are you able to get 3 different solutions, 5 different solutions? Are there infinitely many? Is there only one? You might want to mull that over. Another one, if I give you any gold domino, can you always find an answer? All of these 7 have a solution because I gave you one and maybe you found a different one. It's curious to think about, is it always possible no matter what the gold domino is? And finally, is it always possible to solve the puzzle no matter what the starter ones I give you are? No matter what yellow dominoes I give you, is it always possible to find a solution? These questions and more we will have the answers to in future segments, so stay tuned.